Mr. Clelland here for Clelland Math. So we're doing a differentiation masterclass live here on YouTube right now for higher maths. Just remember that if you like this content and you want more live streams, you can get more as a member of this channel. Just click join now and it's only $8.99 a month, and we're going to go right up to the exams on this. But before we get into this differentiation masterclass, I'm going to go through the whole of differentiation in a nice concise way, not one of my 2-hour long videos or streams, but nice and concise, maybe up to an hour. But before we get into that, let's do an advert from our sponsors, Lecky Scotland. It's sponsored by Lecky, the educational publisher for Scotland. Today we're going to look at practice workbooks for National 5 and higher maths. These are just £5.59 when you use the discount code CLELLANDMATHS at leckyscotland.co.uk, and these are excellent because they have lots of questions topic by topic by topic. So as you're working through the year, you can revise and practice any topic you want and make sure you are comfortable with that topic. But also when it gets towards exam season, a practice exam paper right at the end to make sure you're ready for your exams. Just £5.59 when you use the discount code CLELLANDMATHS. The links are in the description and down below. And we're back, so let's just get started straight away with an example. So we've got on here, given that y equals 5x cubed minus 4 root x plus 1 over 3x, where x is greater than 0, we need to find the y by the x, and we're not allowed to express our answer with any non-integers, so non-whole numbers, or negative powers of x. So when we differentiate, we want to get ready to differentiate first by getting rid of all our roots and all our powers underneath. So I'm going to start with y equals 5x cubed minus 4, now root x becomes x to the power of a half. And 1/3 and then x on the bottom, well, that's a bit weird. With the 1 and the 3 stays where it is, don't be tempted to move that 3, it's just the x. So if you think of the x, it's got a power of 1 at the moment, so it becomes a power of minus 1. And now I can differentiate. So the y by the x is going to be 3 5s is 15, x squared. Take the half down to the front, so minus a half times 4x. And then take 1 away from the power. So a half minus 1 is minus a half. And then minus 1 times a third is minus a third x. And then take away 1 from minus 1 to give me minus 2. And now I need to get it tidied up. So the y by the x, 15x squared is fine with me. A half times 4, well, a half of 4 is 2, so minus 2. But I've got that x to the minus a half, so I'll make that x to the half to start with. And then minus a third, x to the minus 2, so 1 over 3 stays where it is, x squared. I can tidy that up slightly by saying I've got 15x squared minus 2 over, well, x to the half will be root x, so root x minus 1 over 3x squared. And we're done there. Calculate the rate of change of f of t is t plus 3 over t, where t is greater than 0 when t is 2. So if you ever see it saying rate of change, it means differentiate. Differentiation is defined as the rate of change of a function. So if I can understand that, I know that I'm doing f dash t this time. Doesn't matter whether it's a t or an x, who cares? T differentiates to 1. Now, I need to get that ready, which I should have done. 3t to the minus 1. So take 1 down, minus 3t to the minus 2. And I'll assume this is non-calculator, so that's 3 over t squared. So what I do when t is 2, so f dash 2 will be the rate of change, 1 minus 3 over 2 squared, 1 minus 3 over 4, 1 minus 3 quarters is 1 quarter, so the rate of change is a quarter, and we're done there. Example 3 says, find the equation of the tangent to the curve y equals 1/8 x to the 4 minus 5 at the point where x equals minus 2. So if you want an equation of a tangent is a straight line, so I need to find the gradient, which is the y by the x, and then I need to find a point, so I sub x into y to get the point, and use y minus b as mx minus a. So let's find my gradient first, shall we? Gradient is the y by the x. Well, that equals 4 times an eighth, 4/8 x, take away 1, 3, and constants like 5 disappear. So that gives me a half x cubed. So at x equal minus 2, my gradient is a half of minus 2 cubed. Minus 2 cubed is minus 8. Divided by 2, I'm getting minus 4 if I've done that right. So now I need a point. So when x equals minus 2, I need y equaling 1/8 of minus 2 to the 4, take away 5. Well, that's an eighth. 2 twos is 4 times 2 is 8 times 2 is 16. It's going to be positive because it's an even power. So an eighth of 16 minus 5. That's 2 take away 5, which is minus 3. So my gradient is minus 4, and my point is minus 2 minus 3. So y minus b minus minus 3 equals m x minus a minus minus 2, y plus 3 then, minus 4x plus 2 minus minus is plus, y plus 3 minus 4x, expanding the bracket, minus 8. So finally y equals minus 4x, and then minus 8, take away 3 is minus 11. And we're done there. Example 4 says, find the coordinates of the points on the curve y equals x cubed minus 3x squared that have tangents with the gradient of 9. So if it's got a gradient of 9, the tangent, the y by dx equals 9. See what we're doing there? So the y by dx, which is the gradient, of course, equals, take 1 down, 3x squared minus 1. 2 3s is 6. Take away 1 from the power to get 1. And we're saying that equals 9. Well, that's a quadratic. So quadratics need to be equal to 0. So I'll make it equal to 0. Common factor first is 3. X squared minus 2x. 3 3s is 9. And then we need to factorize that as well. So I'm going to factorize that by going double brackets. X and x. 3 and 1. So we've got 3 times 1 is 3, minus 3 plus 1 is minus 2. So therefore, x equals minus 1 and x equals 3. Find the coordinates of the points. Well, I've got an x, I need to find a y. So when x is minus 1, y is minus 1 cubed minus 3 minus 1 squares, which is minus 1. Minus times 1 times minus 1 is 1. 1 times 3 is 3. So that's minus 4. Our first coordinate is minus 1 minus 4. Second coordinate, when x equals 3, y equals 3 cubed minus 3 times 3 squared. 3 cubed is 27. 3 squared is 3 times 3 is 27. That's 0. So the other point is 3, 0. And we're done there. Now let's see if anyone's chatting here. So I think we have got somebody else saying, can you go over circles, please? We've already had somebody saying trigger circles. So remember, I've got a whole of circles video already in the higher maths playlist, but I will do a video like this on circles very, very soon. I'm taking all your feedback and I will definitely do that next. But before we do that, for today, remember, if you want to join this channel, you can get exclusive streams as well. So that might help you with your studies. Just click join now. Example 5. F of x is 5 cos 2x, find f dash 5 pi over 6. So this is differentiating a trigonometric function and using the chain rule. The start of the exam paper tells you how to differentiate sine and cos. So we can just check that. Now I've already memorized that. Cos goes to minus sine. So I get minus sine, still 2x, but I've still got my 5. So it's 5 in front. But I need to remember to times by cos 2x, the 2x part differentiated, which is 2. Now the exam paper does tell you to put the 2 in the front, but that's the same as times and by that differentiated. So that gives me minus 10 sine 2x. I now need to sub in 5 pi over 6. So f dash 5 pi over 6. This looks like it will be an exact value trig part. Minus 10 sine. 2 5s is 10 pi over 6. So that's minus 10 sine. Simplify that to 5 pi over 3. I'm not sure that 5 pi over 3 is an exact value somehow. But is it related? Let's have a look. Cast diagram. So with cast diagrams, we're thinking in terms of pi's. This would be pi plus the angle. This would be pi minus the angle. And this would be 2 pi. So where's 5 pi over 3? Well, if you think about going up, it goes between 0 and pi, 0 and 90, up to 180, up to 2 pi, well 5 pi, well up to 1 pi, sorry, well 5 pi is above that, up to the next one, which is, well, usually 270, isn't it? So what's 270? Well, it's 3 pi over 2, and then up to 360, which is 2 pi. That's clearly in this quadrant here, 2 pi. Now, if you don't know that, change that to degrees. You can do 5 times 180 divided by 3, and you'll see what it is. Let's do that at the side, actually. 5 times 180 divided by 3, because we know a lot of people don't like thinking in radians. 360s is 180, 60 times 5 is 300. So we know this angle is 300 degrees, which is in here. So how do we relate that? Well, that's 2 pi minus something is 300. It's related to 60 degrees. Well, 60 degrees is an exact value. So exact value for 60, we've got 60 here and 30 there. 1, 2, 3 is how I remember it, and that's a root. Sine of 60 is root 3 over 2, but it's negative when it's in this quadrant here, so it's minus root 3 over 2. So finally, we could say that f dash pi of 5 pi over 6 equals minus 10 times minus root 3 over 2. 10 divided by 2 is 5, so 5 is on the top, 5 root 3. Example 6. These are taken from maths.scot, by the way, an excellent maths website, so if you want to check there for revision, it's a good place to look, all free, of course. H of x is 2 over 1 minus 4x to the 5. So this is a chain rule because I've got something in brackets to a power. Get it ready first. 2, 1 minus 4x, 5 becomes minus 5. Differentiate. So differentiate. Minus 5 times 2 is minus 10. I've got 1 minus 4x. And take away 1 to the power, so that's minus 6. But I need to remember to break the chain. And times by the thing that's in the brackets differentiated. So 1 minus 4x differentiates to 4 with a minus on it. So that means I get 4 tens is 40, minus times a minus is a plus, over 1 minus 4x to the 6. Now this is a calculator question, so I'm going to do it with mostly calculator. H dash 1 over 8, 40 minus 1 minus 4 eighths to the 6th. Okay, I'll do it with a calculator, let's go. 40 over 1 minus 4 eighths is 4 eighths, which is a half, to the 6th. Well, what's a half to the 6th? Well, that's going to be 1. 2 twos is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Times by the reciprocal, so that's just going to be 40 times 64 over 1. Can I do 40 times 64 in my head? Let me just zoom in there. Well, 4 fours is 16, 4 sixes is 24, makes 25, 2 5 6 0, and we're done there. But you don't need to be smart like me. You can just use a calculator. When it says use a calculator, and you'll be fine. Example 7. Non-calculator. Find the x-coordinates of the stationary points on the graph y equals f of x, where f of x is x cubed minus 3x minus 2. And then it says, hence determine the range of value for x so that it is increasing. So it's increasing when the derivative is positive. So we have to find the stationary points. Stationary points occur when the y by dx equals 0, and then find when it's increasing. So part A, stationary points when f dash x equals 0. I need to say something like that. So I need to differentiate it to get 3x squared minus 3 equals 0. 3x squared minus 1 equals 0. 3x plus 1, difference of two squares. So we get our stationary points at x equal minus 1 and x equal 1. So part B, if we just imagine we're going along to minus 1 at some point and along, and then we're going along to 1 at some point and along, just keeping it as two separate. And then you've got your f dash x, and this is your x. We're just examining what happens at these places. So we're going to think of a shape. So it was minus 1 at 0, and at 1 at 0, so it's along the way. Pick a number near minus 1. Let's say minus 2, and let's say 2. And then a number in between minus 1 and 1. Just make sure it works at 0. Yeah, let's say 0, 0. So if I put minus 2 into here, I get, we'll just use the factorised form because the numbers are easier. Minus 2 add 1 is minus 1. Minus 2 take away 1 is also minus. A minus times a minus is a plus. So you would get a positive answer in here, and you can take your time to work that out, which means it's going up the way. If you put 0 in, you get 1 times minus 1, which is minus. Same here then. So it's going down the way and down the way. And then at 2, you get 2 plus 1 is 1, 2 minus 1 is 1, 1 times 1 is positive. So we can put positive here, and it's going up the way. So the range of values, so that f is increasing when, well, only when it's positive, so that x is less than minus 1 and x is bigger than 1, because everywhere else is either 0 or going down the way. And there we are, we've done that one. Okay, example 8 says, find the dimensions of a square base cuboid with volume 125 cubed and the minimum surface area. God, that doesn't sound fun, does it? Let's try it. Oh, let's try it. This is obviously optimization. If it says minimize or maximize something, you want to optimize it. So we need to get some variables. So it says a square base cuboid. Let me just try and draw a cuboid, I suppose. Usually you'll be given a picture for this, of course, but in this case we've not. There you go, cuboid. Yeah, square based. Not a very good cuboid. Let's try again. So it's square based. Let me just do a square on the bottom actually like this, and then just join it up the way like that. There you go, that's better, isn't it? Square base cuboid with volume, so we know the volume is 125 centimeters cubed. And minimum surface area. Find the dimensions. Well, if it's square based, we could say that the height is up the way, and it's x by x on the bottom. So it's x by x for the bottom of it. Now, that means that we've got some information here. We have to minimize the surface area. So we're going to have to find out what the surface area actually is. So we need to write something for the surface area. Well, it's x by x, which is x squared. And since it's a cuboid, I'll have 2 of them. And then the sides are going to be x by h, and there'll be 1, 2, 3, 4 of them. So plus 4xh's. So that's 2x squared plus 4xh. Now, usually, at this point then, I need to get rid of that h, so I'm going to do that. The volume is equal to 125. Well, volume is area of the base times the height, which is 125. So that means my height is 125 over x squared. Now, don't worry if you can't do this. This is usually part A. If you can't do it, you'll still get an equation. You'll be given it. So we'll then say that our surface area is equal to x squared plus x squared is 2x squared plus 4x times 125 over x squared, which we can simplify to 2x squared. 4 125s is 500. And then x cancels with x, get 500 over x. So that's my surface area. But usually it says show that that is the surface area. So don't worry if you can't quite get there with that, because you'll have a part B which then says minimize. So let's call that surface area A for the sake of it. Then A dash, or dA by dx for part B. Well, let's make that 2x squared plus 500x to the minus 1. So that's 2 2's is 4x minus 500 x to the minus 2. Now we want to minimize that, so stationary points when A dash equals 0. So we've got 4x minus 500 over x to the minus 2, x squared equals 0. Now a lot of people get stuck on how do we do this one. All you do is make a common denominator. So that's 1. X times x is x squared. 4x cubed then minus 500 equals 0. So then we can just say that 0 times x squared equals the left-hand side. So 4x cubed minus 500 just equals 0. Just as 1, 0, of course. So 4x cubed equals 500. It's just a cubic. So x cubed is 500, 125. Cube root of 125 is 5. So x is 5, and there is only one answer, so you could say that is the answer, but you do have to verify it. So we need a nature table, along to 5 and along, dA by dx. So dA by dx, remember, was 4x minus 500 over x squared. So let's just pick 4 and 6. Well, again, 4 fours is 16 minus 500 over 16, 4 squared. That's still minus anyway, but just to be safe side. And then putting 6 in, we've got 4 sixes is 24 minus 500 over 6 sixes is 36. We can see that's positive. So there's our shape, and therefore x equals 5 is a min TP, so it minimizes the surface area. Okay, the dimensions, well, x equals 5, but h, remember, we've already got is equal to 125 over x squared. So 125 over 5 squared, 125 over 25, which is 5 as well. So it's actually a cube. So then our surface area, we had a formula for that, 2x squared plus 500 over x. So 2x squared is 5. I always forget as I go, plus 500 over x. 2 times 25 is 50. 500 over 5. 5 into 5 goes 1 is 100. So the surface area is 150 units squared. Was it centimetres anyway? Yeah. Don't even need units. It's all centimetres. So let's put our centimetres in. Centimetres squared for surface area, centimetres for height, and centimetres for the dimension. And we're done there. Hopefully that's right. We move on to example 9. Non-calculator again, this one. So we have got, what's Mohammed saying? Not sure, I can't read it right now. I'll go into my chat. Let me just see. Make that a bit bigger. Mohammed saying this is higher. Yes, it is higher. I think someone's just asking, am I going to do that 5, Mohammed? But thank you for that. Thanks for the comment. Okay, example 9. Find the minimum and maximum values in the interval between -1 and 2. So it's possible, right, if we have to find the minimum and maximum in between 2 places, the minimum and maximum could occur in between those 2 places, or the endpoints could be. So we need to check all of them. So we need to check our stationary points. First of all, stationary points when f dash x equals 0. So that is 3 fours is 12x squared. Now 2 nines is 18x. And minus 12 equals 0. A common factor is 6. To get 2x squared plus 3x minus 2. Let's just hope that factorizes. We've got 2x and x. 2 2s is 4 and 1 is 3. So I just need to get my signs right. Plus 4 minus 1. So that means that 2x minus 1 is 0, so x is a half. Or x is minus 2. So we get there so far. X is a half and x is minus 2. But we then need to check are they maxes or minimums. We have to find both anyway. But can we disregard anything? That's a good idea with this question. We have to only do it between -1 and 2. Well, -2 is out width, so we don't need to check that one. No need to check. Because -1 is less than or equal to x less than or equal to 2. So just need to check a half. We also need to check -1 and 2 to see if it occurs at these points. Nature table, along, a half, and along. We don't need to check -2, so that's x, f dash x in the shape. So before a half, we could pick a 0 and 1. Will we do that? So at 0, where's our f dash x? It's here. or we can pick here, but at 0 we get 0, 0 minus 12, that's negative. So negative 0, and at 1 we get 12 plus 18, well that's 18, 28, 29, 30, 30 minus 12, that's positive, isn't it? So that means that we're going along down and up, so x equals half is a min turning point. So now we need to check what happens at minus 1 and 2. So I've got our original equation. Okay, so at x equal to half, f of x equals, well, we've got 4x cubed plus 9x squared minus 12x. And I think it's plus 1, is it? Yeah, it's plus 1. So put a half in there. We get 4 times a half cubed plus 9 times a half squared minus 12 times a half plus 1. A half cubed is an eighth. 4 over 8 is a half. Take your time on that. A half squared is a quarter. 12 times a half is 6. A half plus 9 quarters, well, that's 2 quarters plus 9 quarters, which is 11 quarters. Minus 6 add 1 is minus 5. 11 quarters minus 20 quarters, which is minus 9 quarters. So we know that at that point is minus 9 quarters. We now need to check minus 1 and 2. So at x equal minus 1, f of x equals 4x cubed. So that's minus 1 times minus 1 times minus 1, which is minus 1. So that's minus 4. Plus minus 1 squared is 1, so that's plus 9. Minus 12 times minus 1 is plus 12, plus the 1. 9 minus 4 is 5. 5 plus 1 is 6, plus 12 is 18. And then at x equal to 2, f of x is equal to 4x cubed. 2 2s is 4 times 2 is 8. 8 4s is 32. 2 squared is 4, 9s is 36. I'm just subbing in. 12 2s is 24, minus plus 1. So we've got 36, 68, minus 24, that's 34, 44, 54. 24, 34, 44, 54, 64, that's 44, I think. Plus 1 is 45. So we should have 45 for them. So we've got minus 9 quarters. We have got also 18 and 45. So that means that we can say that our minimum value of f is minus 2 quarters, or 9 over 4, because that's the smallest, and our max is 45. So we just write that. Min is minus 9 quarters at x equal to a half, and max is 45 at x equal to 2, and we're done there on that epically long question. The next one, example 10, is SQA Higher Maths 2017, paper 1, question 3. So I've already actually done this one before, so all I'm going to do here to see if it actually works is I'm going to show you the solution to that one instead of doing it manually. So we're on example 10. SQA Higher Maths 2017, paper 1, question 3. Y equals 4x minus 1 to the 12, find the y by dx. Nice and simple, 12 down to the front, 4x minus 1, take away 1 for the power, but then times the bit in the bracket differentiated, in other words, times 4. 4 times 12 is 48, 4x minus 1 to the 11, job done. SQA Higher Maths 2017, paper 1, question 8, on differentiating a polynomial, calculate the rate of change of the t. D of t is equal to 1 over 2t. So we need to get it ready to differentiate. Always need to do that. So d of t is equal to 1 over 2 t to the minus 1. Do not be tempted to move this 2. That's just a half still. Separate it out. It's just the t that's moving. Once we do that, d dash t, take the minus 1 down, so we get minus a half t. Take away 1 from the power, we get minus 2. Now we have to work it out when t is 5. So d slash 5 is equal to minus a half times 5 to the minus 2, or minus 1 over 2 times 5 squared minus 1 over 2 times 5 squared is 50. So minus a 50th. Just a note, remember, rate of change means differentiate. On nature, SB Higher Maths 2017, paper 2, question 7. Find the x-coordinate of the stationary point on the curve with equation y equals 6x minus 2 root x cubed. Then find the greatest and least values of y in interval 1 is less than or equal to x and less than or equal to 9. So part A, stationary points occur when the y by the x is 0. So we need to get ready to differentiate. So with part A, I've got y equals 6x minus 2. I've got x cubed, so the cubed comes along for a ride, but it's a square root, so it's over 2. The y by dx then, 6 minus 2 times 3 over 2, x to the half, because I take away 1 from the power, and then we can say that stationary points occur when the y by dx equals 0. So making this equal to 0, we get 6. These 2's cancel, so minus 3. X to the half equals 0. So 3x to the half equals 6. X to the half equals 2. Remember, x to the half means the square root of x equals 2. So I'm looking for, if I square both sides, I get x equals 4. And we're done there. Part B, hence determine the greatest and least values of y. So at x equal to 1, y equals 6 times 1 minus 2 times the square root of 1 cubed. 6 times 1 is 6, minus 2 equals 4. At x equal to 9, the other one, y equals 6 times 9, minus 2 times the square root of 9 cubed. 6 times 9 is 54, minus the square root of 9 is 3, so 2 times 3 cubed. 54, 3 3's are 9 times 3 is 27, 27 times 2 is 54, that gives me a big 0 is the answer at the limits. So now I need to evaluate it at x equal to 4. So at x equal to 4, we've got y equals 6 times 4, minus 2 times the square root of 4 cubed. 24 minus 2 times the square root of 4 is 2, so 2 cubed. 24, 2 cubed is 8 times 2 is 16. 24 minus 16 is 8. So then we can just state our greatest and least values. The greatest value is 8 and the least value is clearly 0. So greatest value equals 8, least value equals 0. And we're done there. Okay, the next one we're going to do, example 13, SQA Higher Maths, paper 2, question 3 on 2018, had the function f is defined on a set of real numbers as f of x is x cubed minus 7x minus 6. Determine whether f is increasing or decreasing when x equals 2. Sub 2 in actually, wasn't even paying attention, so subbing 2 into f dash 2, we get 3 times 2 squared minus 7. And if that's positive, it's increasing, if it's negative, it's decreasing. So 3 times 2 2's is 4, is 12, minus 7 is 5, and I knew it was 5 and I wrote 5, but I mean 7. 12 minus 7 is 5, and therefore f is increasing at x equal to 2. SQA Higher Maths 2022, paper 1, question 12. Given that f of x equals 4 sine 3x minus pi over 3, find f dash pi over 6. This is a chain rule. Now, the chain rule at the start of exam paper only gives sine ax and you put the a in front. It never mentions another bit. But that bit just gets ignored because you differentiate 3x minus pi over 3 and the pi over 3 disappears. So just to show you, f dash x, sine goes to cos. So I've got 4 cos 3x minus pi over 3. Then I just times by the 3 because 3x, the number in front of x. 3 4's is 12 cos 3x minus pi over 3. Subbing in pi over 6. you get 12 cos 3 pi over 6 minus pi over 3. That's 12 cos. Well, let's examine this. Pi over 3 is 2 pi over 6. So it's 3 pi over 6 minus 2 pi over 6, which is 1 pi over 6. Well, that's an exact value. Let's do a triangle. Pi over 6 is 30 degrees, I think, because 6 30s is 180. So now what we can do is we can put 1, 2 and root 3 here. And then what we're doing is 60 cos, no, it's 30 cos, opposite adjacent root 3 over 2. So we get 12 root 3s over 2. 12 divided by 2 is 6 to get 6 root 3. Example 15. SQA Higher Maths 2023 Paper 1 Question 1. Find the y by dx for this. So get it ready to differentiate. X to the 5 thirds minus 10x to the minus 4. The y by dx then. 5 thirds comes down, x minus 1, so minus 3. 5 minus 3 is 2 thirds. Minus times a minus is a plus, 40x minus 4. Well, take away 1 is minus 5. And it just says find the y by dx. It doesn't say simplify it or anything. You don't have to. But maybe on the safe side, we could write 5 thirds x to the 2 thirds plus 40 over x to the 5. Or if we want to be really fancy, we could write 5 thirds x to the 2 thirds is the cube root of x squared plus 40 over x to the 5. But there's no need to go that far. SQA Higher Maths 2023, Paper 2, Question 10. Determine the range of values for which the function f of x is 2x cubed plus 9x squared minus 24x plus 6 is strictly decreasing. There's actually two ways to do this. Both involve stationary points. If you get the stationary points, you can then examine the graph to see where the derivative is negative, or you can just examine the nature of the stationary points. So let's just look at the stationary points first. Stationary points occur when f dash x is 0. So f dash x gives me 6 2's is f dash x, 3 2's is 6, 6x squared, 2 9's is 18, plus 9 18x, and minus 24. And I'm going to look at that equal to 0 for our stationary points. 6 is a common factor, so I get x squared plus 3x minus 4 equals 0. So double bracket that up. X and x. 4 and 1 make 3, plus 4 minus 1 makes 3. So that implies our stationary points occur when x equals 1 or x equals minus 4. So then there's two ways to go now. I'll give you both options. I'll use the nature table. If you're using a nature table, you'll go along to minus 4, along, and then along to 1, and then along. And then you're just going to examine the derivative. So looking at our derivative, a number before minus 4, let's try minus 5. Minus 5 minus 1 is minus 6. And minus 5 plus 4 is minus 1. A minus times a minus is a plus. So it's positive there. It's 0 here. Between these two numbers, let's just try 0 then. Minus 1 times 4 is minus. It's negative there, so it's still negative there. It's 0 there. And then a positive number like 2. 2 minus 1 is 1. 2 plus 4 is 6. Positive times a positive is a positive. So it's increasing before minus 4. And then it's a turning point. And then it's decreasing. Still decreasing, of course. And then it's increasing. So we could say strictly decreasing when minus 4 is less than x is less than 1 in between those two numbers. Or if you, and that works as well because the function is continuous. If it was discontinuous, it should be a little bit knackered, but we know it's continuous because it is. Now, if we move on to the other way, we could look at just the graph. So graph of the derivative, we know the derivative is quadratic with station points at minus 1 and 4. So 1 and 4, so 1 and minus 4, sorry. So 1 and minus 4, and it's a normal there. So same idea, that's the graph of the derivative, that's the graph of f dash x, and that's negative below the x-axis, which is down here. So it's between -1 and 4. So again, you would stay the same answer. -4 is less than x is less than 1. Either of those options will give you your marks probably. Okay, welcome back. So we're on example 17 now. SQA Higher Maths 2024 last year, paper 1, question 3. Given that y is 5x squared plus 3 to the 7th, find the y by dx. So this is a chain rule. Remember, you have to break the chain. The y by dx, I'm such a dad joke. 5x squared plus 3, so I write 5x squared plus 3 again. 7 comes in front, and it becomes a 6. But now I need to times by whatever 5x plus 3 differentiates to. Well, 5x squared differentiates to 10x, and 3 disappears. So that is 7 times 10 is 70x. 5x squared plus 3 to the power of 6. And we're done there. Example 18, SQA Higher Maths 2024, paper 1, question 12. Maths.Scott says this is question 11, but it's actually question 12 I checked. SQA Higher Maths 2024, paper 1, question 12. A function f is given by f of x is 12 cube root of x is greater than 0. And it says when x equals a, the rate of change of f with respect to x is 1. Rate of change differentiation. Find the value of a. So let's differentiate it. To find the rate of change. So I'm going to need f of x in a differentiable form. So I'm going to say 12x to the cube root of x. Cube root is a third. So that means I've got a third times 12x. Take away 1 to the power, minus 2 thirds. A third to 12 is 4. So I get 4x to the minus 2 thirds when we differentiate. And it says when f of a, when x equals a, the rate of change with respect to x is 1. So when x equals a, so f dash a, f a minus 2 thirds equals 1. So we need to solve this equation. So there's lots of ways you could do this, but I'm going to actually just put it back into 4 over a to the 2 thirds equals 1. So that means that a to the 2 thirds equals 4. So what is a to the 2 thirds? That's the cube root of a squared equals 4. So if I just cube both sides, that'll give me a squared, and 4 fours is 16 times 4 is 64. And the square root of 64 is 8, and x is greater than 0, so it is just 8, and we're done there. Okay, this has been Clelland Maths. This has been a good time to kind of stop there. This has been the whole of a masterclass on higher maths differentiation, preparing you for your SQA Higher Maths, SQA Higher Maths 2025 exams. I'll be doing lots more of these masterclasses. I've also got my membership option that is not to be pushy. You can join it if you want, and you can get much more content, exclusive content for whatever course you are studying. But I think we'll stop there today. If you want any further help with differentiation, I would suggest you check the Higher Maths playlist. I've got the whole of differentiation for Higher Maths already in there, much longer and more in depth than this video can ever be. But this gives you a good stepping stone for your differentiation topic. Take care, stay safe, and goodbye.